Welcome to a new episode.
Hello and welcome back to the Copper Connection podcast with me as always, your host Chris Bailey. Over the next 3 weeks we're kicking off a level 2 plumbing revision mini-series designed to help you tighten up your knowledge, boost your confidence and walk into that exam fully prepared. Today's episode is a deep dive recap into cold water systems, and this is a big one. We're not just skimming the surface or reading from the spec, we're breaking down the how and why behind every key part of the system, so it actually makes sense on site and in your exam, whether you're listening on the bus, in the van or in the workshop. This episode is built to help you to lock in the technical details, avoid common exam mistakes and understand the system from start to finish. So grab a brew, settle in and let's get started into cold water systems. Our story begins with the rainwater cycle. It's a continuous loop. The sun heat causes evaporation, water turning into gas, which then condensates, which is gas turning back into a liquid droplet to form clouds. When these clouds become saturated, we get precipitation, which is rain, snow or sleet. Once that water hits the ground, it's collected from two types of sources. Number one, surface source. Lakes, rivers, reservoirs. These are easily contaminated by animals or runoffs. And then we have number two, underground sources, which are wells and boreholes. These are often filtered naturally by the rock, but can still carry minerals. Because this water isn't safe yet, it goes to a treatment plant. First, it's filtered with slow sand filters, using a biological layer called a smudge deck to eat away bacteria, while rapid filters force water through the sand and gravel. Finally, the water is sterilised. Bit of an exam tip, the exam often asks the final stages of treatment. We add chlorine in to kill any remaining bacteria and viruses, ensuring that the water is safe by the time it hits the mains. Now let's talk about the 5 fluid categories, the plumber's Bible as I call it. This is the most heavily tested area of cold water systems. You must know these categories by heart because they dictate what backflow prevention you can install. So we have category 1 water. Wholesome potable drinking water. This is what comes out of your kitchen tap. Then we have category 2, which is category 1 water that has been changed aesthetically. It might be warmer or have a different taste or smell, like the water in your kettle. Category 3, slight health risk. This water containing relatively non-toxic substances. Think of soapy water in your basin or bath, or the water inside a central heating primary circuit. And in category 4, significant health risk. These contain toxic substances. For example, inside a garden hose where pesticides could be sucked back, or a commercial heating system, or a swimming pool. Then we have category 5 water, which is a severe health risk. This is the danger zone. It contains fecal matter or dangerous bacteria. Think of WCs, urinals, or rainwater or greywater systems. Remember the S rule for the risks. 3 is slight, 4 is significant, 5 is severe. This is a crucial part of the system layout that often appears in diagrams. Water starts its journey to the property from the water main in the road. It's connected via a component called a ferrule. From the mains to the property boundary, the pipe is called a communication pipe. This section is owned and maintained by the water undertaker themselves. At the boundary, you'll usually find a boundary stop tap chamber with a hinge cover. This is where the water meter is typically located. Once the pipe crosses that boundary and enters the customer's land, it changes its name. It's now the service pipe, and it is the responsibility of the property owner to maintain it. To protect the water from freezing, this service pipe must be buried to a depth of 750 millimetres to 1,350 millimetres. A key fact, if it's shallower than 750 millimetres, it will freeze in the winter. If it's deeper than 13,500 millimetres, it becomes too difficult and dangerous to dig up for repairs. The pipe is usually MDPE, which is medium density polyethylene. That's the blue plastic pipe. When it enters into the home, it must be inside a 75mm duct that is insulated and sealed at both ends to prevent rodents from entering into the house. It transitions to copper. The first thing you must install is the main internal stop valve, followed immediately by a drain-off valve. From this point up, it is known as the rising main. Okay, let's have a brief look at direct and indirect systems. How do we get that water to the taps? We have two choices. First one, direct systems. Every tap in the house is fed directly from the rising main. Pros: high pressure at all taps, wholesome water everywhere, and no need for a big tank in the loft. Cons: well, if the mains are turned off for repair, the house has no water. This is where there is also a high risk of water hammer, noisy pipes. Then we have number 2, the indirect system. Only the kitchen sink is fed from the mains. The rising main goes up to the loft and fills a cold water storage system. All of the taps, bath, shower, toilet are fed by gravity from that tank. Pros: well, you have a reserve of water, usually around 230 to 250 litres if the mains fail. The pressure is consistent and low, which reduces wear on the valves. Cons: you need space for the tank and you must protect that tank from freezing in the winter and overheating in the summer. Backflow and air gap. We must prevent against back-siphonage, where there's a drop in the mains pressure, sucking dirty water directly into the clean supply. We have two types of mechanisms. We have mechanical protection. We use check valves. A single check valve is used for category 2 risks, like mixer taps. A double check valve is used for category 3 risks, like an outside tap or a heating filling loop. And then we have non-mechanical backflow prevention, which is all our air gaps. This is the safest method. There's 4 air gaps I need you to remember. You've got an AG air gap. This is the space between the inlet and the top of the water in a tank. AUK1 specifically for WCs, which protects up to category 5. AUK2 for basins, baths and bidets up to category 3. And AUK3 for kitchen sinks, which is a category 5. AUK2 is for basins, baths and bidets. AUK3 is for kitchen sinks because it's a high risk area. Now let's take a look at some of the valves, taps and hard water. Stop valves, British Standard 1010. These have a rising spindle. They are designed for high pressure systems and are used to isolate the main supply. Gate valves, which is British Standard 5154, these have a non-rising spindle and a full-way bore. They offer very little resistance, making them perfect for low-pressure gravity systems. Then we have flow valves, British Standard 1212. We have Part 1, the old Portsmouth style. Never used in domestic houses now because the outlet is at the bottom, meaning it can't guarantee an air gap. Parts 2 and 3, these have an outlet at the top to ensure an air gap. Part 2 is brass and Part 3 is plastic. Hard water. If a customer has line scale issues, a water softener is the only true way to remove the calcium. It uses ion-on exchanges, resin beads. Note, the kitchen tap must remain unsoftened for drinking. Soundness testing and commissioning. Before you sign off, you must test the system for copper or low carbon steel or LCS. We fill the system and check for obvious leaks. This is what we call a visual inspection. Once the water has been put into the system, we wait for 30 minutes for the temperature to stabilise. As we're aware, water is its heaviest at 4 degrees, so we give it 30 minutes to go from 2 to 4 degrees. Once that's happened, we then put the system up to 1.5 times the working pressure. We leave it for an hour. If the pressure holds, it's sound. If it drops, we need to investigate. So if the working pressure is 3 bar, you test your system to 4.5 bar, which is 3 times 1.5. Finally, you're commissioning. This means flushing pipes to get rid of the flux and metal filings, checking that the flow operate valves shut off at the correct level, usually 25 mil below the overflow, and ensuring the flow rates meets the manufacturer's requirements. Okay, so that brings us to the end of our cold water masterclass. We've covered everything from the clouds to the kitchen tap. and from the boundary meter to the final soundness test. Remember, the exam isn't just trying to catch you out, it's checking you can be a safe, competent plumber who protects public health. If you're feeling overwhelmed, just come back to the basics. 750 to 1350 millimeters deep, 1.5 times working pressure, and always protect category 1 water. You've put in the hours, you've listened to the details, and now you've got the knowledge locked in. Take a deep breath, read those questions twice, and trust your training. Thanks for joining us on this journey through the pipes. Until next time, keep joints tight and your pressure steady. I've been Chris Bailey, and this has been the Coffee Connection Podcast.
We'll be back next week. In the meantime, please subscribe and thanks for listening.